Welcome to the comprehensive guide on Puppet interview questions focused on system configuration management. Puppet is an open-source configuration management tool that automates infrastructure provisioning using a declarative programming model. The core components you need to understand include manifests, which are .pp files, resources and classes for code organization, modules and templates for reusability, and the master agent architecture for distributed management. The key principle behind Puppet is the declarative approach, where you define the desired state of your system rather than the specific implementation steps. This ensures consistent system states across your entire infrastructure. Puppet manifests are the foundation of configuration management in Puppet. These are Ruby-based configuration files with a .pp extension that define the desired system state declaratively. Manifests contain resource declarations and classes that serve as the entry point for Puppet automation. A basic manifest structure includes resource types like package and service declarations. For example, you can define a package named Apache2 to be installed with ensure set to installed, followed by a service declaration to ensure Apache2 is running and enabled. This declarative syntax allows you to focus on what you want rather than how to achieve it. Puppet resources are the fundamental building blocks for managing system components. The core resource types include package for software installation, service for managing system services, file for file management, and user for managing user accounts. Resource declaration follows a specific syntax where you specify the resource type, followed by the resource title in quotes, and then the attributes within curly braces. For example, a file resource can specify the path, ensure it is present, define the content, and set the mode permissions. A user resource can ensure a user is present and specify the shell. These resources form the basic elements that Puppet uses to manage your infrastructure. Puppet modules provide a structured way to organize and distribute reusable code. The key benefits of modules include reusability, allowing you to share and reuse code across multiple environments, organization through logical grouping of related code, and distribution via the Puppet Forge marketplace. A standard module structure includes a main module directory containing manifests folder for .pp files, files folder for static files, templates folder for ERB templates, and a metadata.json file containing module information. This organized structure makes it easy to manage complex configurations and share modules with the community or across different projects. Puppet classes provide advanced code organization and reusability patterns in your infrastructure automation. Classes offer several key benefits, including encapsulation to group related resources together, reusability to use the same class across multiple node definitions, parameterization to accept variables for customization, and inheritance to extend and override base classes. A class definition starts with the class keyword, followed by the class name and optional parameters in parentheses. For example, an Apache class can accept parameters for package name and service name with default values, then define package and service resources using those parameters. This allows for flexible and maintainable code that can be customized for different environments. Declarative system management is the fundamental approach that sets Puppet apart from traditional scripting methods. The key principles include desired state configuration, where you define what you want rather than how to get there, idempotency, ensuring the same result regardless of execution count, and state convergence to automatically correct drift from the desired state. The difference between declarative and imperative approaches is significant. With declarative Puppet, you simply state ensure Apache is installed and running, while traditional imperative methods require you to specify every step like download, install, configure, and start Apache. This declarative approach focuses on outcomes rather than procedures, making your infrastructure code more maintainable and predictable. The Puppet master agent architecture provides centralized configuration management for your entire infrastructure. The workflow follows 4 key steps. First, agents check in with the master every 30 minutes by default. Second, the master compiles a catalog specifically for each node based on its assigned classes and modules. Third, each agent applies the catalog locally to configure the system according to the desired state. Fourth, agents report back to the master with the results of the configuration run. This architecture allows you to manage hundreds or thousands of servers from a single central point, ensuring consistency and compliance across your entire infrastructure while providing detailed reporting on configuration changes. Common Puppet interview questions focus on core concepts and practical implementation. Key questions include explaining idempotency in Puppet, which means running the same configuration multiple times produces the same result without unintended side effects. You should understand the Puppet catalog compilation process, where the master gathers facts from agents and compiles node-specific catalogs. Puppet facts are system information like operating system version, memory, and network details used for conditional logic. Resource dependencies are crucial, and you can handle them using require and before attributes, or using arrow notation like package Apache arrow service Apache. Understanding these concepts and being able to explain them with practical examples will help you succeed in Puppet interviews. Following Puppet best practices ensures reliable and maintainable configuration management. Key development practices include storing all Puppet code in Git repositories for version control, using RSpec Puppet for comprehensive unit testing, implementing peer review processes for code quality, and always testing with Noop flag before applying changes to production. The recommended deployment workflow starts with development where you write and test code locally, followed by staging where you deploy to a test environment first, then validation to verify functionality and performance, and finally production rollout to live systems. These practices help prevent configuration errors, ensure code quality, and provide a safety net for infrastructure changes. To master Puppet system configuration management, focus on these core concepts. The declarative approach means defining desired state rather than implementation steps. Resource management involves managing files, packages, services, and users as basic building blocks. Code organization uses manifests, classes, and modules for scalability and maintainability. Idempotency ensures the same result regardless of how many times you run the configuration. For interview preparation, make sure you understand the master-agent communication flow. Practice writing basic manifests and classes. Know the best practices for version control, testing, and security, and study resource dependencies and ordering relationships. With these fundamentals mastered, you will be ready to excel in Puppet configuration management interviews and succeed in infrastructure automation projects.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.